Here we're going to look at a quick revision video for right angle triangles. Now, there's a couple of rules we need to remember with right angle triangles, and these should be familiar with us quite a bit at the moment. They're going to become very useful for solving angles of elevation, angles of depression, obviously for solving right angle triangles, and any other application that would produce maybe a right angle triangle. So let's go ahead and draw a right angle triangle. Try and draw it to the best of my ability here on the tablet. Now, a right angle triangle will be always donated with a 90 degrees either symbol like this in L. It could also be, I'll rub this one out and show you, it could also be a box to show a right angle, or they could put in 90 degrees there. On this triangle we have a side A, B and C, and we have two other angles that can be in there. We have beta and we have alpha. Now, a couple of rules we can take from that. I'll get a different colour pen just so we don't confuse ourselves too much. Pythagoras' theorem. Pythagoras' theorem is obviously a very familiar one, hopefully. He implied that c squared equals a squared plus b squared. So what does that mean? Well, c squared is the hypotenuse. So we can find the hypotenuse if we know the other two sides, or indeed if we know the hypotenuse on one of the other sides, we can rearrange this formula to find it. So ultimately c is the square root of a squared plus b squared. The hypotenuse is also the longest side. It's going to be the longest side in the right angle triangle, and it's always, the hypotenuse is always opposite the 90 degrees. Okay, so a couple of things there we've learned about that. If we know all the sides in a triangle and we know all the angles, we have solved the triangle. So solving the triangle involves finding all the sides. Generally we'll use Pythagoras' theorem to do that, or we'll look at another way to do it, and find the angles. Now, depending on which angle you're finding, if we're finding alpha, B will be the adjacent side to alpha and A is then opposite it. For beta, A is the adjacent and B is opposite. Okay. The next set of rules we're going to look at, and I'll do this in another colour, is SOHCAHTOA. And SOHCAHTOA can also be remembered as silly old Hitler couldn't advance his troops over America. SOHCAHTOA. And that gives us our trigonometric ratios. And what it does is it gives us sine, cos and tan. Now we'll do this in relation to alpha. So the sine of alpha here will equal the opposite, which is A, over the hypotenuse, which is C. The cos of alpha will equal the adjacent, B, over the hypotenuse. And the tan of alpha will equal the opposite, which is A, over the adjacent, which is B. Now obviously these would be different if we're doing beta. It's also very important to note that this is a ratio. In here we have an angle. So if we're getting the sine of an angle, we get a ratio out. It's no dimensions. If we then get the inverse of the ratio, we will get the angle, and that can be in degrees or radians. So very important distinguishment there.